This video is sponsored by Bosch Automotive Service Solutions, a globally trusted partner for all workshop needs. Visit boschdiagnostics.com for more information.
Direct fuel injection is not a mystery. It's actually a 2-for-1 deal. On this vehicle, there's actually 2 fuel pumps. There's a volume or supply pump in the tank, just like on a normal port fuel injected vehicle, and there's also a high pressure fuel pump on the fuel rail and on the engine. These two work together along with the other sensors on the engine to deliver the correct amount of fuel directly to the cylinder. This makes sure that the vehicle meets emissions and is also very efficient and also powerful. The fuel pump in the tank, well, that's just like a conventional fuel pump. It's an electric pump that will be driven by a pulse width modulated signal. So what does that mean? It means that it has a signal going to it of a 12 volts turning off and then on, off then on. The interval that it's turned off will determine how fast the pump is spinning. So if you have a duty cycle of 25%, that means voltage is turned on 25% of the time. If you have a voltage duty cycle of 70%, that means that the fuel pump is turned on 70% of the time and it's spinning a little bit faster. As for data PIDs from the volume or supply pump that you really need to look at, well, it's overall pressure at the rail it's delivering, the duty cycle of the pump, and then also other indications for the evap system, just in case. This way you're going to be able to evaluate the condition of the pump in the tank to make sure that it's functioning properly and delivering the correct amount of fuel to the rail and the high pressure fuel pump. The high pressure fuel pump underneath the hood, well, it's driven by the exhaust camshaft in some cases. It can be driven by lobes or driven directly in some cases. This high pressure fuel pump can generate up to 3,000 and in some cases on some late model vehicles, 5,000 psi. So how does it do this? Well, typically you have a plunger and a pump. This goes up and down as the lobes go past. But that pump itself has a solenoid on the side that controls how much fuel is put into that cylinder and how much of it is being compressed. This solenoid is pulse width modulated too, just like the fuel pump in the tank. This solenoid controls how much fuel is going into the pump and how much is delivered to the injectors. If you're diagnosing a high pressure fuel pump, there's a couple of different data PIDs that you need to pay attention to. First of all, the high pressure transducer that is between the pump and the fuel rail. With this, you could see how much output that high pressure fuel pump is putting out under certain conditions. Also, the other data PID you need to look at is the duty cycle for the solenoid on the high pressure fuel pump. With these two, you can help diagnose what's going on with the pump. If you're dealing with a lean code or under-delivered pressure on some pumps, you can look at this to see what's the duty cycle and what's the pressure. But it's not just these two components on the vehicle that make a direct fuel injection system work. In other words, the camshaft position sensor, the crankshaft position sensor, the oxygen sensors, the mass airflow sensor all have to be functioning properly for the system to work and deliver the right amount of fuel to the cylinder. If there's issues with any of these, it can affect how much fuel is being delivered to the cylinder and if it's correct for the conditions. In other words, make sure that you're looking at all of the possible things that could go wrong before you replace a pump. This way you can make sure that it's not the supply pump or volume pump or the high pressure pump. You can make an educated decision and also confirm what is wrong with the vehicle. I'm Andrew Markel. Thank you very much.
This video is sponsored by Bosch Automotive Service Solutions, a globally trusted partner for all workshop needs. Visit boschdiagnostics.com for more information.